Yo, 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 Mac by the Moon, back with another video. Today, I'm going to be showing you solving logarithmic equations, some one-to-one, and some where you have to actually exponentiate in order to solve. So we're going to be using our log properties to condense, and then if we do get a problem that's logs on both sides and we can cancel off the common logs or the same logs with the same base, then we'll do so. If not, we'll rewrite it as a base power answer so we can then evaluate or solve the equation that remains. So, you ready? Ooh, let's get it. So let me share this with you. Over here on my document camera, I have my first problem. And what you see is not my document camera, is this. Now you see it. Okay. Let's make it a little gooder. Let's make it a little gooder. All right, so we got this problem. It has log base 2 of x plus log base 2 of x minus 4 equals 5. Now, I know by looking at this, and since I've seen several of these problems and I teach math, I see I'm not going to be able to get a one-to-one log because I don't have a log over here where this 5 is. I'm only going to be able to condense, and I'm only going to be able to exponentiate this in order to solve it. There is no chance that I'm going to have a log on both sides of this problem. Okay, so with that being said, let's go ahead and turn this addition into, get it up top, don't say, what's addition turn into? Multiplication. Good. So log base 2, whoops, log base 2 of x times x minus 4 equals 5. So I condensed the addition into multiplication. Focus, there we go. So now I have it condensed. I can take this 2, raise it to the 5th power, which is 32, right? So we'll rewrite this as 2 to the 5th power equals, and I'm going to do x times x minus 4, distribute that. Okay. And I know I'm recognizing here that I have a quadratic. I have a second degree, which means I have 2 possible answers. So 32 is what this equals, 2 to the 5th. And I have to bring this over to bring this 32 over to the other side so I can hopefully factor it. So my factors of 32, there's a bunch, 1, 32, 2, and 16, 4 and 8. 4 and 8 will work if I make the 8 negative, so it'll be negative 8, positive 4. They're my factors. And again, my solutions are my zeros, 8 and negative 4. Now, up here I wrote a little couple reminders for us. We want to try and condense first. We condense if we want to, so we can leave our log. We couldn't leave our logs behind in this problem. We couldn't cross them out. But if my friends can't solve a logarithmic equation, you ain't no friend of mine. So then we exponentiated this problem, which means that that's the step we took right here where we base power answered it, rewrote it out as an exponent question, and then we solved it from that point forward. Now we do have to check for extraneous solutions. So in the notes that I provided you in your email this week, I said that you cannot do the log of a negative number. It's impossible. Try to figure out a way to raise some base to some power that gives you a negative. It'll never be done. You can also never do the log of 0. So any of these answers that we might get that when plugged in up here could potentially give us a negative, we're not even going to say that they would be real solutions. They're considered extraneous solutions. They're extra unnecessary solutions we get in the process of solving it. So if I were to take this 8 and plug it in, I can do the log base 2 of 8. And that'd be 3, right? 2 to the 3rd would be 8. And over here, I can do the log base 2 of 8 minus 4 would be 4. So the log base 2 of 4 is 2. And then that would be 3 plus 2 is 5. So 8 checks out. 8 works. But if I were to take the log of negative 4 and stuff it in up here, you can't do the log of a negative number. And it doesn't matter what base it is. So if I just do the common log of -4 is what we're doing, right? Whoops. Error, non-real answer. So there you go. You can't do the log of negatives. Same thing. If I go to it and I change it to the log of, I told you can't do the log of 0 either, right? Error, domain. You can't do the log of 0. So it's not possible. So -4, if I plug that in any of these, it's going to be considered extraneous because I cannot do log of a -4. Cannot do the log of -8. If I plug -4 in here, I'd have to be doing log of -8. So always check for extraneous solutions. You cannot have log of a negative number or the log of 0. These are extraneous. All right, so let's take a look at my next example. And here I have this one set up. So if you look at it, I think we are going to be able to use one-to-one properties here. Still, we condense if we want to, so we hopefully could leave our logs behind. And if my friends can't solve a one-to-one log, you ain't no friend of mine. So addition turns into multiplication. And as you can see now, the logs can cancel off. That's why we said they're one-to-one logs. The logs are the same base on both sides. These are common logs because they're base 10. We can cancel out our one-to-one logs. Up here, I did not, at that previous example, I did not have the opportunity to get a one-to-one log because no matter what I did, once I condensed these, I always had just a regular 5 over here, not a log that I could, log base 2 that I could cancel out. So back to our question at hand. Now we have this, looks like it's going to be a quadratic because if I distribute this, I'd have x squared minus 4x equals -7x plus 21. I'd move these both over so I could get it equal to 0, add 7x, and subtract 21. So I'd have x squared plus 3x minus 21 equals 0. So what did I do? I think I wrote something wrong. I think I wrote this 4. It was supposed to be a 3. I think it was supposed to be a 3. Yeah, I copied the problem wrong. Sorry. So, sorry about that. If you're jotting this down, that was just my mistake. It won't factor if I didn't do that. So then I'd have to use a quadratic formula, which I don't really want to do. But anyway, and you won't have to in this unit, so it's not a big deal. We're all human. I am human. So we have x, and what multiplies to get -21 adds up to get 4. I know I'm going to need a +7 and -3, which means my potential solutions are -7 and 3 for my zeros. Now, same thing we had to check for in this first example. We have to check to see if we end up with extraneous solutions. So one thing's for certain, -7 is extraneous right off the bat, because as soon as I plug it in right here, I get the log of the -7, which can't be done. So that one's extraneous. Now, let's check out the 3, right? If I plug the 3 in right here, it works. I can do the log of 3. It's a positive number. I can do the log of any positive number. Over here, I'd end up with the log of 0. And like we said before, you cannot do the log of 0. I showed you in my graphing calculator. It doesn't make any sense. So 3 is actually extraneous as well. So there's really no good solution to this problem. There's no real solution to this problem. You only get 2 extraneous solutions. So you got to watch out for these in edgenuity. Okay. So keep in mind, you cannot do the log of negatives and you cannot do the log of 0. And I think you'll be fine. All right. If you need any extra help or you want to hop on a Zoom, let me know. Later.